NENOMATICA, where mathematics meets YouTube excellence. Welcome! In this example, we'll simplify an algebraic expression step by step, highlighting the key rules at each stage. Our goal is to simplify the expression. Step 1. We add the terms inside the first parentheses by writing the linear part over a common denominator of 1 plus x. Using the fraction addition rule, we get the quantity open bracket numerator is 1 minus x times 1 plus x plus 4 plus x squared, all over 1 plus x close bracket times 1 minus x squared. Step 2. Now, simplify the numerator. The product 1 minus x times 1 plus x is 1 minus x squared. So the numerator becomes 1 minus x squared plus 4 plus x squared, which simplifies to 5. That yields 5 over 1 plus x times 1 minus x squared. Step 3. Factor the difference of squares. 1 minus x squared equals the product 1 minus x times 1 plus x. Now we have 5 times 1 minus x times 1 plus x all over 1 plus x. Step 4. Cancel the common factor 1 plus x from numerator and denominator. Note the domain restriction, x cannot equal -1 because of the original denominator. After cancellation, the result is 5 times 1 minus x. The expression is 5 divided by, open parenthesis, x to the minus 1 plus y to the minus 1, close parenthesis, all raised to the power -1. We will assume x and y are not 0. Step 1. Use the negative exponent rule. A to the power -1 equals 1 over a. So we replace x to the -1 with 1 over x, and y to the -1 with 1 over y inside the parentheses. Step 2. Add the fractions inside the parentheses. 1 over x plus 1 over y equals y plus x over xy. Substituting that in, the denominator becomes the quantity y plus x over xy, still to the power -1. Step 3. Apply the negative exponent to invert the fraction. The quantity over b to the power -1 equals b over a. So the denominator becomes xy over x plus y, and the whole expression is 5 divided by x, y over x plus y. Step 4. Dividing by a fraction is the same as multiplying by its reciprocal. A divided by b over c equals a times c over b. Therefore, our expression equals 5 times the quantity x plus y divided by xy. Final answer: 5 times x plus y divided by xy. This simplification used 3 key ideas: rewrite negative exponents as reciprocals, combine fractions, and then invert with the negative exponent before multiplying by the reciprocal. We will proceed step by step, using sign flips to align denominators, then combine over a common denominator, and finally show the numerator collapses to 0. Step 1. Write the original expression clearly so we can track changes. We use sign flips to rewrite denominators in a consistent order. The key observation is 1 over b minus equals -1 over a minus b. Apply this to the second term. For the third term, flipping both factors contributes 2 negatives, which multiply to a positive, so no sign change overall. Step 3. Notice all 3 denominators now share factors a minus b, a minus c, and b minus c. This invites a common denominator. Combine the 3 fractions over the common denominator, which is the product of a minus b, a minus c, and b minus c. We are using the standard rule for adding fractions with the same denominator. Multiply each numerator by the missing factor to place everything over the common denominator. Expand the numerator terms and combine like terms. b minus c minus a plus c plus a minus b. Everything cancels. b minus b is 0, negative c plus c is 0, negative a plus a is 0. A 0 numerator over a non-zero denominator equals 0, provided a b and c are distinct so none of the factors vanish. Therefore, the entire sum is equal to 0. We'll begin by writing the original expression clearly, then we will clean up the complex fractions, factor where possible, and cancel common factors. Strategy. Step 1. Turn the division by a fraction into multiplication by its reciprocal. Step 2. Rewrite each complex fraction with a single numerator and denominator using common denominators. Step 3. Factor sum and difference of cubes. Step 4. Cancel common factors carefully. Step 1 and 2. Replace the division sign with multiplication by the reciprocal. Now rewrite each complex fraction using common denominators. The top left becomes x squared plus y squared minus xy, all over xy. The bottom left becomes x squared plus xy plus y squared, all over y squared. 1 plus y over x becomes x plus y over x. The last complex fraction becomes, after reciprocating, x cubed times x cubed minus y cubed over x, y times x cubed plus y cubed. Next, we use factoring identities. X cubed minus y cubed equals x minus y times x squared plus x, y plus y squared. X cubed plus y cubed equals x plus y times x squared minus x, y plus y squared. Apply the identities to the difference and sum of cubes. Notice we have a lot of structure that will cancel out soon. Now gather the factors to see what cancels. We can cancel x cubed over x cubed, y squared over y squared, x plus y, x minus y, and x squared plus xy plus y squared. After canceling common factors, what remains is the factor x squared plus y squared minus xy in the numerator, and x squared minus x, y plus y squared in the denominator, multiplied by x plus y over x plus y. Those x plus y factors also cancel, leaving the same trinomial both on top and bottom, which equals 1. Therefore, the entire expression simplifies to 1. In this example, we will simplify a complex fractional expression step by step using common denominators and the idea of dividing by a fraction as multiplying by its reciprocal. Step 1. Simplify the numerator and the denominator differences by putting them over common denominators. The numerator 1 minus the fraction becomes parent a plus b close parent minus parent a minus b close parent, all over a plus b. The denominator fraction minus 1 becomes parent a plus b close parent minus parent a minus b close parent, all over a minus b. Step 2. Combine like terms in each numerator. The top becomes 2b over a plus b. The bottom becomes 2b over a minus b. Step 3. Now rewrite the original division as multiplication by the reciprocal. We have 2b over a plus b times a minus b over 2b. Notice the factor 2, b appears in both numerator and denominator. Step 4. Cancel the common factor 2, b, from the numerator and the denominator. After canceling, the expression simplifies to parent a minus b close parent over parent a plus b. Important note about the domain. From the original expression, we must have a plus b not equal to 0, a minus b not equal to 0, and b not equal to 0 because we simplified by canceling 2b. So the final simplified form is left parent a minus b right parent over left parent a plus b right parent with those domain restrictions. Here is the expression to simplify. Notice the cyclic symmetry in A, B, and C. Step 1. Split each numerator, sum over its product, in the denominator. For example, b plus c over bc becomes b over b, c plus c over bc, and similarly for the other two terms. Next, simplify each of those tiny fractions. b over bc is 1 over c, c over bc is 1 over b, and similarly we get 1 over a and 1 over c, and 1 over a and 1 over b for the third. Now, we distribute, but only to the extent we need to see the cancellations. We will write every produced term, arrange them in rows, and then cancel opposites. Watch the symmetric cancellations. Each positive fraction has a matching negative fraction elsewhere. After all cancellations, only the linear terms remain, 2a, 2b, and 2c. Combine like terms, that is a plus a, b plus b, and c plus c, giving 2a plus 2b plus 2c. Then factor out 2 to get 2 times a plus b plus c. The key ideas were symmetric splitting into unit fractions, careful distribution, and then recognizing perfect cancellations. The final simplified expression is 2 times a plus b plus c, symmetric splitting into unit fractions, careful distribution, and then recognizing perfect cancellations. The final simplified expression is 2 times a plus b plus c. We need to simplify the expression. 3 over a squared minus 16, minus 2 over a minus 4. Step 1. We factor the difference of squares in the first denominator. a squared minus 16 equals left parenthesis a minus 4 right parenthesis times left parenthesis a plus 4 right parenthesis. Now rewrite the expression with the factored denominator. Step 2. To subtract rational expressions, we need a common denominator. The common denominator is left parenthesis a minus 4 right parenthesis times left parenthesis a plus 4 right parenthesis. Rewrite the second fraction so it has the same denominator. Step 3. Since the denominators match, combine the numerators. We get 3 a minus 2 times left parenthesis a plus 4 right parenthesis, all over left parenthesis a minus 4 right parenthesis times left parenthesis a plus 4 right parenthesis. Step 4. Distribute and simplify the numerator. 3 a minus 2 a minus 8 simplifies to a minus 8. So the entire fraction becomes a minus 8 over left parenthesis a minus 4 right parenthesis times left parenthesis a plus 4 right parenthesis. A quick note about the domain. Since a minus 4 and a plus 4 are in the denominator, we must have a not equal to 4 and a not equal to negative 4. Here is the example we will solve. We want to simplify over the quantity 3 plus a over the quantity 3 minus a plus 2 a squared over 9 minus a squared. Step 1. Factor the difference of squares in the last denominator. 9 minus a squared equals the product of the quantity 3 minus a and the quantity 3 plus a. Now rewrite the expression with that factorization in place. Step 2. Create a common denominator equal to the quantity 3 minus a times the quantity 3 plus a. Multiply the first fraction by the quantity 3 minus a over the quantity 3 minus a, and the second fraction by the quantity 3 plus a over the quantity 3 plus a. Here is the rewritten sum with a common denominator. Step 3. Since all terms share the same denominator, we can combine the numerators over that common denominator. Step 4. Expand the numerator using the distributive property. A times the quantity 3 minus a becomes 3 a minus a squared. A times the quantity 3 plus a becomes 3 a plus a squared. Step 5. Combine like terms in the numerator. 3 a plus 3 a equals 6a. Negative a squared plus a squared cancels, and we still have plus 2 a squared. That yields 6 a plus 2 a squared over the common denominator. Step 6. Factor the numerator. 6 a plus 2 a squared equals 2 a times the quantity 3 plus a. Step 7. Cancel the common, factor the quantity 3 plus a from numerator and denominator. We obtain 2 over the quantity 3 minus a. Finally, state the domain restriction. A cannot equal positive 3, and a cannot equal negative 3, because those would make a denominator 0. Recap. We factored the difference of squares, built a common denominator, combined the numerators, factored the result, and canceled a common factor to reach a simplified rational. Factored the result and canceled a common factor to reach a simplified rational expression. Let's display the example and the problem statement. Step 1. Use a common denominator to combine the fractions. Here, the common denominator is x squared minus 4. So we rewrite the sum as a single fraction. The numerator becomes 3x times x minus 2 plus 12x minus the quantity 3x squared minus 12, all over x squared minus 4. Step 2. Expand the numerator using the distributive property. We get 3x squared minus 6x plus 12x minus 3x squared plus 12, all over x squared minus 4. Step 3. Combine like terms in the numerator. The 3x squared terms cancel, and minus 6x plus 12x becomes 6x. So the expression simplifies to 6x plus 12 over x squared minus 4. Step 4. Factor both numerator and denominator. Use a greatest common factor in the top and difference of squares in the bottom. We get 6 times x plus 2 in the numerator, and x minus 2 times x plus 2 in the denominator. Step 5. Cancel the common factor x plus 2. We are left with 6 over x minus 2. Note that the domain excludes x equals 2 and x equals negative 2 from the original expression. So the simplified result is 6 over x minus 2 for x not equal to plus or minus 2. In this lesson, we will simplify a rational algebraic expression step by step. We'll factor, find a common denominator, combine, and simplify to get a very clean final result. Here is the problem we will simplify. Notice the mix of denominators. a minus 1, a squared plus a plus 1, and a cubed minus 1. Our strategy is to factor the cubic denominator and then bring everything to a single common denominator. First, factor a cubed minus 1 using the difference of cubes formula. The difference of cubes factorization is a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Here b equals 1. So a cubed minus 1 equals a minus 1 times a squared plus a plus 1. Rewrite the original expression, replacing a cubed minus 1 with a minus 1 times a squared plus a plus 1. The common denominator is a minus 1 times a squared plus a plus times a squared plus a plus 1. Convert each fraction to this common denominator. The first term multiplies top and bottom by a squared plus a plus 1. The second term multiplies top and bottom by a minus 1. The third term is already over the common denominator. Now that all three terms share the same denominator, combine them into a single fraction. Expand the numerator carefully and combine like terms. Multiply a plus 5 by a squared plus a plus 1. Then subtract 6 times a minus 1, and subtract 6 times a squared plus 2. When simplified, the numerator becomes a cubed minus 1. Replace the numerator with a cubed minus 1 and factor it as a minus 1 times a squared plus a plus 1. Now cancel the common factors in numerator and denominator. As long as it is not equal to 1, and a squared plus a plus 1 is not 0, this cancels to 1. So the simplified value of the original expression is 1 equal to 1, and a squared plus a plus 1 is not 0, this cancels to 1. So the simplified value of the original expression is 1. Recap. Notice we have a polynomial part, and then a rational term. Our goal is to combine everything into a single fraction, and then look for a clever factorization. Step 1. Get a common denominator of 1 plus x. We rewrite the entire expression as 1 fraction over 1 plus x. That means we multiply the polynomial part by 1 plus x over 1 plus x, and then subtract x cubed over 1 plus x. Step 2. Use the sum of cubes identity. Recall, a plus b times a squared minus a b plus b squared equals a cubed plus b cubed. Here, let it be 1 and b be x. So 1 plus x times 1 minus x plus x squared equals 1 plus x cubed. Step 3. Substitute the identity into the numerator. The numerator becomes 1 plus x cubed minus x cubed, which simplifies to just 1. Therefore, the entire expression equals 1 divided by 1 plus x. Here is the expression we want to simplify. First, recognize two classic square trinomials. 1 minus 2x plus x squared is the square of 1 minus x, and 1 plus 2x plus x squared is the square of 1 plus x. Next, factor 1 minus x to the fourth. 1 minus x to the fourth equals 1 minus x squared times 1 plus x squared, and 1 minus x squared further factors as 1 minus x times 1 plus x. Now rewrite the original expression using these factorizations. Replace the two trinomials and 1 minus x to the fourth accordingly. We can simplify the fraction by canceling one factor of 1 plus x in the numerator and denominator. That leaves the fraction as 1 minus x times 1 plus x squared, divided by 1 plus x. To add these two terms, use a common denominator of 1 plus x. Write the first term as the same numerator divided by 1 plus x, multiplying top and bottom by 1 plus x. Now factor out the common 1 minus x from the numerator. This gives 1 minus x times the bracket, where the bracket is the product of 1 minus x and 1 plus x plus 1 plus x squared. Simplify the bracket. The product 1 minus x times 1 plus x is 1 minus x squared. Add that to 1 plus x squared, and you get 2. Therefore, the simplified result is 2 times 1 minus x divided by 1 plus x. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.